All right, I'm Brian Forrest. I'm going to be talking about the two postulates of special relativity. So, first of all, a postulate is just a statement that is assumed to be true in order to uphold a theory. So, the two postulates of special relativity are just two assumptions that the scientific community makes in order to support the theory of relativity. So the first postulate is this. It states that the laws of physics are the same and can be stated in their simplest form in all inertial frames of reference. So the key to this postulate is understanding what an inertial frame of reference is. An inertial frame is either an object that is completely at rest or an object that is in uniform motion. Basically, it's not accelerating. It's moving at a constant velocity. It's not accelerating, not slowing down. It's not like changing direction at all. And the laws of physics will apply universally regardless of what inertial frame you're in. So it doesn't matter if you're here, it doesn't matter if you're across the country or on the other side of the world, the law of gravity is going to affect everyone the exact same way. At the same time, it doesn't matter whether you're in a plane that's moving at a constant speed or at a car that's moving at a constant speed. The laws of physics will apply universally regardless of what inertial frame you're in. Now, the thing that's interesting about this is, obviously when we're on Earth, we have a frame of reference. We can say that that plane is moving because we see it, traveling past clouds, or we see a car go through an intersection, we can say that it's moving. When you're in space and you don't have a reference point, it's impossible to tell what is in motion and what is at rest. So imagine in space there are two objects and the objects are getting closer together. There is no experiment that we can perform in order to tell whether object A is moving towards a stationary object B or whether object B is moving towards a stationary object A. I mean, there's no way to tell because the laws of physics apply universally regardless of the inertial frame. Now, the second postulate of special relativity is this. It says that the speed of light, c, is constant, independent of relative motion of the source. For this, I like to imagine that I'm on a float in a parade and I'm throwing candy. Now, since I'm on the float, I'm moving with it. So for me, in my inertial frame, I don't experience anything out of the normal. And if I throw candy, let's say 10 miles an hour off of the float, I will see that candy move at 10 miles an hour. Now, if I'm a bystander, rather than being on the float, if I'm watching the parade and I see the float moving 10 miles an hour, and then I see someone throw candy 10 miles an hour in my direction, I'll see the candy move 20 miles an hour. If both the float and the candy are being thrown in my direction, I will see the velocities add and the candy will move at 20 miles an hour. If I'm behind the float and it's moving away from me and someone throws candy at exactly the same velocity that the float's moving, the candy's just going to drop. At least from my inertial frame, I will see the candy drop. Now, the postulate doesn't apply to that. It applies to the speed of light. So instead of candy, let's assume that I have a flashlight and I am on the float. If I turn that flashlight on and a bystander is standing in front of the float, one might assume that I will witness the flashlight, or at least the light coming from the flashlight, travel at the rate of the speed of light plus whatever velocity the float's moving. That's not true. That's where the second postulate comes into play. It states that basically light is an exception to the rule, saying that it will always be constant regardless of however fast its source is moving. So even if it's like a really high speed, even if the flashlight were moving at half the speed of light, the speed that the light is emitted will never exceed c. It won't ever be greater than that. So those are the two postulates of special relativity.